Precipitation over the central Andes is the principal water source for the dry southern coast of Peru, the Altiplano region, and the upper part of the Peruvian and Bolivian Amazon. In this region, agriculture is the main economical activity and strongly depends on the rainfall and climate variability.
Several studies have documented rainfall variability over the central Andes at interannual time scale. For example, it is known that during El Niño years, extreme droughts occur in the central Andes, producing strong impacts on agriculture and economy of this region.
However, not all of the strong El Niño years produce extreme droughts in this region, which suggests the role of other phenomena controlling climate variability in central Andes.
While the most of previous studies have focused on interannual rainfall variability over the central Andes, few efforts have been dedicated to low-frequency variability, including decadal and interdecadal time scale. So, our main objective is to document a decadal and interdecadal hydroclimatic variability over the central Andes. In addition, the causes of this low-frequency variability are analyzed and discussed in relation to low-frequency variability of global sea surface temperature and atmospheric circulation.
In this paper, the authors studied the variability of precipitation in the central Andes using hydrological data set as a proxy of the rainfall over this region. They used stations from the southern coast of Peru, central Andes, and the upper part of the Bolivian Amazon.
So, the stations are located at different altitudes that go from 50 to nearly 4,000 meters above sea level.
Thus, analyzing the hydrological time series of each station, we identified that these are characterized by a common wet and dry period, which suggests a possible common variability in the central Andes. Following a statistical analysis, a low frequency variability with oscillations around 8 to 20 years appears dominant. This can explain that wet and dry common periods over this region. This variability is related to the change in sea surface temperature in the central western Pacific Ocean and the zonal wind at 200 hectopascal above the central land.
The results are particularly interesting considering our understanding of rainfall variability over the central Andes. Indeed, while El Niño played a relevant role in modulating rainfall variability at interannual time scale, central western Pacific sea surface temperature have a major influence over rainfall at decadal and interdecadal time scale.
In addition, these results suggest that the intensity of hydrological impacts over the central Andes during El Niño events may be influenced by the low frequency variability documented in this study.